Welcome students to our new YouTube channel Pharmatech, the division of excellence. So let's start to our new chapter in pharmaceutical engineering, which is crystallization. So in the crystallization, we will see the definition of crystallization and also what is crystallization. The crystallization is the natural or artificial process of formation of solid crystals from a uniform solution. Crystallization is also a chemical solid liquid separation technique in which mass transfer of a solute from the liquid solution to a pure solid crystalline phase occurs. The crystallization process consists of two major events. The first is nucleation and the second one is crystal growth. Next, let's see the first major event in crystallization, which is nucleation. The nucleation, it is the step where the solute molecules dispersed in the solvent start to gather into clusters on the nanometer scale, elevating solute concentration in a small region that becomes stable under the current operation conditions. The stable clusters constitute the nuclei. Nucleation can occur spontaneously or induced artificially by any foreign substance. These two cases are referred as homogeneous and heterogeneous nucleation respectively. The next major event is crystal growth. The crystal growth, it is the subsequent growth of the nuclei that succeed in achieving the crystal cluster size. It occurs through four stages. The first stage is transport through or from the bulk solution to an impingement site, which is not necessarily final site. And the second is absorption at impingement site, where precursors may shed solvents molecules. Hence, solvent must be transported back in solution. And the third is diffusion of growth units of precursors from site of impingement up to growth site. The fourth is incorporation into lattice. For precursor after desolvation, thus the growth site may also be a source of solvent that has possibility of again being adsorbed before escaping into the solution. The nucleation and growth continue to occur simultaneously while the supersaturation exists. Supersaturation is the driving force of the crystallization, hence the rate of nucleation and growth is driven by the existing supersaturation in the solution. Depending upon the conditions, crystals with different sizes and shapes are obtained. Once the supersaturation is exhausted, the solid liquid system reaches equilibrium and the crystallization is complete unless the operating conditions are modified from equilibrium so as to supersaturate the solution again. Next, we will see the theories of crystallization. The Myers supersaturation theory. The Myers supersaturation theory, it is well defined curve for any defined condition of heterogeneous nucleation can be established in supersaturation zone, which is parallel to solubility curve. Then next we will see the methods to achieve supersaturation. The first method is by cooling. It is applicable when solubility depends on the temperature, like inorganic salt, organic substances. At high temperature, solution is saturated, and at low temperature, solution is supersaturated. The second is by evaporation of solvent. It is applicable to those whose solubility independent to temperature, like NaCl, that means sodium chloride. And the third method is by addition of third component. The first is salting out. It is applied when solubility of substance is very high, so supersaturation is difficult by method 1 and 2. The second is precipitation and the third is by pH change. The next we will see the crystallization equipment according to supersaturation method. The first crystallizer is tank crystallizer. The method is cooling, and the tank crystallizer is uses and its characteristics are global salts, synthetic sponge for only batch process, and global salts. The second crystallizer is Swenson-Walker crystallizer and the method is cooling, and its uses and characteristics are the Swenson-Walker crystallizer. It has spiral agitator run at 7 rpm revolution per minute to prevent accumulation of crystals. The next crystallizer is crystallizer. The method is cooling, and also the crystal evaporator is also known as OLSO crystallizer, and the method is evaporation. And the last crystallizer is magma crystallizer, and the method is evaporation. And the uses and characteristics of magma crystallizer are: it is propeller agitator used to lift magma, not used when refrigeration temperature required to obtain good yield or solution has large boiling point elevation, and not used for salt which has flat solubility curve. So here is the end of the chapter crystallization. Hope you like this video. So if you like this video, please comment on comment section, and please share this video to your GPAT aspirant as well as CET aspirants more and more. So thanks for watching this video. Next we will see the next topic, which is evaporation. So please stay tuned to our YouTube channel, and please subscribe our YouTube channel. Thanks for watching video. Thank you, thank you, thank you, thank you. Welcome students.